Hello, ladies and gentlemen. Well, let's see here. You know the drill, right? Starting off with our review. In chapter 8, section 3, remember this was the FOIL or box method, whichever one you wanted to use. Remember that FOIL is first. Oh, I don't know why it's not writing. That's dumb. Sorry. First, there we go. O is for outer, I is for inner, and then L is last. So remember that when we are talking about our first and last terms, we're talking about first in each set of parentheses. Last is the last in each set of parentheses. Where with outer and inner, we're talking about the whole thing altogether. The outside terms, which would be here and here, and then the inside terms would be next to each other on the inside. Sorry about that announcement, but I'm not restarting this. Anyway, alright, section 2, when you're multiplying a monomial by a polynomial, remember you're just using the distributive property. And when you do that, remember to also multiply the coefficients and add your exponents. And then, of course, distribute also to this 5, multiply the coefficients. We don't have any exponent other than y to the third. Now with the GCF, you look at what they have all in common. If you look here, 7, 14, 42, they are all divisible by 7. So we know that 7 goes into all of these. Aside from that, we have b to the third in our first term, b squared in our second, and we do not have a variable at all in our third, which means 7 is the only GCF. So we take 7 out, and we divide every term by 7. So we're left with b to the third plus 2b squared plus 6. There we go. Adding and subtracting the polynomials, change only the coefficient, add only like terms. Remember the same combination of variables and exponents. If you have x squared y, that is the same as yx squared. Okay? However, if I change it up and make this xy squared, that is not the same as x squared. Sorry. Why? Because in the first one, x's exponent is 1, and in the second, x's exponent is 2. And then same with the y. So these are not like terms. These two up here are. Change only the coefficient. Remember, the coefficient is the number in front of the variable. So 8 would be the coefficient. 20 would be the coefficient. But y to the fourth is not like with y to the third, so you cannot add them. All right. Moving forward into section 4, multiplying special cases. Woohoo! We are still using the FOIL method or box method. Same thing. So you remember doing FOIL, right? F-O-I-L. First means first in each set, 4x times 2x. O, outer, which means outside of the whole thing. Inner, inside of the whole thing. And then last term in each set of parentheses. So we end up with 8x squared, 16x, negative 6x, negative 12. Combine your like terms, which would be these two right here, and we get 8x squared plus 10x minus 12. Ta-da! Alright, so remember that's your FOIL. And with the box method, if you make a box, and so here we have our box. We add to it our rows and our columns. I guess I said that backwards, huh? Each one, so 4x here, negative 3 there, 2x up here, and then a positive 4. The only reason I wrote this plus sign right here is to remind you that this 4 is positive. Multiply. So think of it almost kind of like you're finding the area of the square by doing length times width. Alright, so 8x squared here, multiply 16x, multiply these ones, negative, I'm sorry, not 2, negative 6x, and then our last term would be a negative 12. Combine like terms, which would be our middle two again, and you result in the same answer. 8x squared plus 10x minus 12. All right, sweet. Rock on. Okay, so what's different now? Well, sometimes the original problem will look different, and it's considered a special case because it looks different. So if you look at the way this is written, this does not look like our previous exam had two binomials written out separately. We don't have that anymore. So you're thinking, what? And then you're getting scared. You don't know what to do. All right, well, let me just go ahead and fix that for you because it is not that bad. All right, anything else that's different? Well, your answers could look different after you simplify them. We're used to problems like this where our middle two terms can be combined, and so our end result, our end solution, has only 3 terms. Other times, we have had terms, or the first problem looking like this, where what ends up happening is we have no like terms. I guess it's already written, huh? Well, now you have it twice. You lucky, lucky people. Anyway, no like terms here, so we have 4 terms in our answers. All right, so those are the 2 things that we've seen, but now it's going to be a little bit differently. All right, so let's go ahead and rock these problems. Yeah, that's right, I said that. All right, first question to you is, what does it mean to square something? Well, when you are squaring something, remember that you are multiplying by, whoa, what was that? You're multiplying by itself. All right, so x squared means x times x, right? Okay, well, what if you look at this example here, 3x minus 2, and that whole quantity is squared? What in the world does that mean? Well, squaring it and everything in the parentheses, so you take that term, 3x minus 2, and you multiply it by itself, and you get 3x minus 2 again. So now we are squaring it because we are multiplying it by itself. And this little box right here holds a little secret for you. Da-da-da-da, secret! Rewrite it. Foil or do the box method and then simplify. So the only difference from our previous stuff is the beginning, the way that it looks as of right now, and then we're just going to foil it or use your box method, whichever you feel the most comfortable with, and go from there. So what we end up with is 9x squared minus 6x minus 6x, and then a positive 4. Combine our like terms, 9x squared, oops, not plus, that is a minus, minus 12x plus 4. There you go, no like terms, we are done. And this I just did quickly, the FOIL method. If you need it slowed down, take your time, you can check your answer. Now you'll look, this term right here is negative 6x. This was my outer term, all right? That was when I took the outside of the whole problem, okay? Now this term right here, that one, is the inner. So that's when I took the 2 that were next to one another. Okay, so that's your inner. And you'll notice that they were the same. The reason they are the same is because we're taking something and multiplying it by itself. Yeah, well, how about them apples? All right, well, let's do another one. What do you think this says? Da, 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 da. Rewrite, foil or box, simplify. Okay, so let's do it. Rewrite 5m plus 3 times the quantity of 5m plus 3. All right, foil it, box, whatever you want to do. Coefficients, multiply. Bases for the variables, multiply, add exponents. So there's my first term, outer, 15m, inner, 15m. Last is 9. Combine like terms, 25m squared. These 2 in the middle are like terms, so plus 30m plus 9. Also notice that I did not change the exponent, okay? I only changed the coefficient here. So here's our answer. Isn't it pretty? All right, so, well, there you are. Just keep on. All right, so now you're thinking, okay, well, you said that we would have some answers that look different, and so far we don't. They all look the same, so clearly you're lying to me. Well, no, I'm not. This one is going to look different. Now, first thing, what do you notice about this? 3h plus 4 times the quantity 3h minus 4. They are opposites only with the one number, plus and minus. So when we go through box methods inside FOIL the last couple of times, if we set up that box and we do our multiplying, look at what will happen with our final answer because they are opposites of one another. So we're going to take this one and write it down the side. So 3h, and then we have a positive 4. And I'm going to take this one hither and write across the top 3h minus 4. All right. So remember, you're multiplying, finding area of this box essentially. Multiply coefficients, multiply variables, add exponents. Moving on. Then you get negative 12h there. All right, now positive 4 times 3h gives you 12h. And then our last positive 4 times negative 4 is negative 16. Now what you will notice is our like terms right here are opposites of one another. They are, and I'm going to go ahead and math you right now. Yeah, that's right. I used math as a verb. Additive, inverse. I don't know if you remember that, but that's what it is. So what we end up with is 9h squared. I'm going to write out the whole thing anyway so you can see just what is going on. These two terms are like terms, but they are opposites. So if I had 12 things and I took 12 things away, well, guess what? I don't have any more of those things. So all I have left is my answer is 9h squared minus 16. Very different from what you're used to seeing, right? Well, it's just because of this sign change here. When these are switched like that, we now have no middle term. We still use the same method to find out the answers. The middle term is just different than what we're used to seeing. Okay, so just a little short repeat. Look here. Only one term has opposite signs. So both the 3's are positive. The two m's, one is negative, one is positive. So we go through the entire box method. Let me go here. We set up our box. And remember, when you're doing the boxes, really it's like finding the area of each individual box. Okay, that's really all it is. Fancy, not fancy schmancy. 3, negative 2m. Write that one down the side. Up top 3 and a positive 2m. All right. Multiply here, 9. Multiply here, 6m. Multiply here, negative 6m. And then multiply here. Remember, multiply coefficients first, and then variables, add exponents. So we have 9 plus 6m minus 6m minus 4m squared. Well, that didn't look like a 2 at all. And check out those middle terms, guys. What? Opposites. 9 minus 4m squared. Whoa. This is amazing. There you are. I mean, I know you think it's amazing, right? Yeah, because it really is. Okay, now I have a certain warning. Warning, warning, warning. I wish I could have sirens going off because I need to tell you that for your safety, oh no, that's spelled wrong. Pretend that didn't happen. My bad. For your safety and the safety of those around you, please refrain from making the following error. Use of the following error will result in incorrect solutions. Check this out. See what happened here? They took this exponent and said, oh, well, the square is here, so I can just do this, right? No. No, you can't. Now, here's why. What you're thinking of is if we had something like this, and we would distribute that exponent, right? But what does this problem have? A plus sign. When we add in a plus sign or a minus sign, there is no more distributing. So don't do it. Don't do it, don't do it, don't do it. And I can tell you right now, some of you will come in. We will practice this in class, and you will do it. But I am warning you, don't do it. Always rewrite it and then multiply. So always rewrite, because what happens when you don't rewrite it and you just try to distribute that exponent, you completely leave out the inside and outside terms. You have totally left out the fact that you have these two being multiplied and these two right here being multiplied. All you really did was first and last. Well, and last I checked, the term was not to use the full method, it was the FOIL method, right? Well, you don't want to leave out your oi. That would be upsetting. Alright, so in summary, take these as they are. Exponent, don't you dare distribute that exponent. Don't do it. And why? Why? Because of that plus sign. Alright, always rewrite it as a product. Remember, product means multiply of two binomials. So, one more time. Are you ready for this? Can you handle it? Rewrite, FOIL, or box, and then simplify. Always do it. Always do it. If you do that every time, you are guaranteed to be ridiculously successful. Alright? So listen, and this is very important, my last piece of advice. You need to stop it before it stops you.